It's my pleasure to do like a very brief introduction to the movie that Herwig van Gauner, with the collaboration with Ryan Martinez, did. SCI-Arc was invited to be part of advanced geometry at the Center Pompidou in Paris. This was in August of this year, August, September, October run for 3 months, in which some of the leading schools in the world were invited to produce and bring information in the video format or other format about how they are approaching the role of technology, particularly with an interest in the notion of robotics and computational scripting applied to design. So there's a couple of points that I want to make, which I think is interesting. One is always seems that architecture is some sort of a crossroad between what technology means and how technology changes the design. It seems like that in the last 20 years has been going on steroids, but actually has been always a central problem, and how radical and experimental architecture always been associated with that historically. But what I think is unique about this is every school or every period of time always try to capture, but this, to do a movie and capture particular time with a bunch of faculties discussing the work and the ideas of what they do and they do with the students and put it together, it became like a really interesting kind of coherent cacophony in a very strange way about the way that SCI-Arc tried to deal with the thing, which is, I will call it a kind of non-religious approach to the problem of technology. And I think in that sense, the movie does a really good job in doing that. The other interesting thing is technology sometimes could be very unforgiving, and you're going to see that in the close-up of high definition video does to the face of some of the people talking into this video, which is kind of an intimidating thing to see. So it is also make us aware of the danger of the power of technology. But what I think was interesting, and we all were excited with it, when the film was done and was set up, is that it presents SCI-Arc as a kind of a big ideological umbrella, but not necessarily with kind of accepting technology as it is, but always trying to figure out the way to challenge and how to reshape how that can be applied in relation to the design, to architecture in a particular way. So anyway, I don't want to extend myself because we're gonna screen the film, and then Herwig with some of the faculties that they were part of the movie will have an informal conversation, and hopefully you guys will jump. I think it's an important discussion, even though it's on a Friday and have like an informal tone, because all of you, the students, in one way or another, are involved with a very quick shifting landscape of technology in relation to design right now. So I think that the film doesn't give all the answers, but I think introduce the possibility of a whole series of discussions that are happening right now in the school. So hopefully you guys are willing to engage into the conversation. And of course, we have the wine in the back to keep you happy and to keep you around. But let's hold it as much as we can so that the conversation can go somewhere. So I think we're going to screen the movie, and then Herwig will take it away from there. Thank you.
I think the idea of representing a school as a progenitor of what's current and exchanging sort of congratulatory at one level and competitive at another level exchanges between people and schools, and maybe some of this is avoidable, but I always thought SCI-Arc in its best sense was separate from that to the extent that it was possible, that SCI-Arc was a more introverted kind of environment. I think that's much less true now. But that it doesn't have to validate itself by demonstrating its connections to places that are supposed to matter, but instead would make a determination based on who was teaching and who was studying what we thought would matter. That doesn't mean it's so insular. SCI-Arc is not insular. I think SCI-Arc's job is to make the people who make the radical, which is different than saying SCI-Arc's job is to dispense some kind of pro forma that makes you radical. I think SCI-Arc is a great place if there are great people at SCI-Arc who will tell you, you can tell me what you think it is, and I probably would disagree. And what I'm interested in is the tension between possibilities.
I think that is important to put in the context too, in the way how these studios are done in SCI-Arc. And SCI-Arc is a peculiar place with a peculiar group of people in which practice in the professional life in relation to the research is a very symbiotic relationship, so it's absolutely crucial. And also, I'm interested that the students are stimulated in that direction. I'm interested that the students, they become people who can lead ideas and not people who will become necessary employees for other people. At least in my own interest, there is a desire of the idea of how you can choreograph and incorporate the accident, or how you can choreograph and incorporate the unexpected into a fairly controlled environment. Some of the students are really good at it and they develop techniques in relation to it. Like, for example, recently we were working with the idea to produce cuts, and very brutal cuts in the way that it's done into animals and not in the way that it's done in surgery. Or in some cases like butchery and so on have to do with the relation between flesh and bones. So there's a kind of opportunistic development of the technique, which usually we don't tend to do that in the formal project in relation to digital technologies. But at the same time, I will say they're not really that they're not new techniques when it comes to art or architecture historically, but I think put in that context, I think it produces very interesting and kind of unpredictable outcomes. That's one thing. And the other element is, like many of the other people here teaching on SCI-Arc, is we all are invested in our own practices. So for me, teaching is also based on the logic of what I don't know, or what I'm interested to explore, or what I'm interested to go. So this idea of regions and mutilations and external agents of contamination of accident, it comes also for the need of people like me doing working for 10 or 12 years with computers, and so you start to feel the necessity, the desire to produce a certain kind of level of corruption or some level of transformation within the work because you've been doing it for so long. The robotic house that we initiated a year and a half ago, it was initiated under the notion that it's not clear what we can do with it. And I think that's the best attitude to our technology. You have to get it and figure out what you need to do it. But the learning and the production of the discourse happening in doing it, not in predefining it. I think we are in an era of post-manifesto. I don't think you can set up the manifesto first and then figure out what is technology that fits you better. I think it's a much more dynamic relationship.
Where I position like my work and maybe my friends' work or the people whose work I'm interested in respect to a kind of after digital movement, let's say processes and forms as opposed to, or objects is another way that people have talked about it, as opposed to technology and affects. The way that it ends up showing up in some of the work that I do in my office is currently dealing with sand deposition and sand subtraction and scanning and 3D projection and sort of combining all these things into a kind of real-time design interface or set of design tools. It has its application, but it also is producing all kinds of new and weird things with a kind of real-time interactive physical model that's based on sand deposition and landform. If you have real-time control over and feedback introduced into a process of representation and fabrication, it doesn't have to be that direction. You don't have to start with a drawing and then produce an object. You can start with an object and produce a drawing and change it and then feed it back through a process of fabrication. And so it doesn't just mean that you're collapsing the distance between something and creating a kind of immediate interface in the way that we've typically dealt with digital environments, and then moving that into the material realm, which I think is fascinating, meaning the robot becomes a kind of physical interface, real-time interface that manipulates a model in the same way that we used manipulating digital models, right? There's a possibility of completely removing that digital model altogether and dealing with the robot as the sort of production interface. But if you can do that, you can flip the direction of those things, you can squish them together, you can move them apart, you can introduce things into them whenever you want. And that to me is what's interesting about real time. Not that it's the answer to everything, but it's the sort of final problem to be solved in controlling that distance. And once you can do that, everything can be changed.
One of the aspects that I'm most interested in has to do with the geometry question, but in specific terms, the way that there's robotic motion, and again, this curved geometry rather than vectoral geometry. And we're finding that while the robots are incredibly precise, there's also certain particularities and singularities that are only discovered in real time in the lab, and they're distinct from what can be modeled or simulated in the computer. And I think it's the kind of schism between what you can simulate and what actually you can produce in the lab that starts to engage new kind of modes of representation for the students. So we're interested going forward in really engaging those possibilities. Well, the setup of the lab is actually quite unique relative to any other school of architecture. There are 6 robots. They're small payload robots, and there's 3 that are set up in a kind of cooperative organization, and then 2 larger robots that are also set up in a cooperative organization. Several students that were at SCI-Arc who've gone on to become research fellows at the school, they've actually helped to write a kind of a translator, we call it Esperanto, and that translates between Maya and the actual native language Val3 of Stabli Robotic. What's fantastic about this kind of translator is that from a design perspective, the students can stay in a platform that they're primarily comfortable with, where they can animate, they can rig the motion control in Maya, and then that goes through the Esperanto translator and gets executed in real time in the lab through Val3. And I think that's something that's specific to SCI-Arc and not at any other school.
The idea of bringing robots was the idea of scrutinizing robots, not saying, oh, here's a robot, great, it's the next, CNC machine or something like that. It wasn't like that at all. It was much more speculative. Is it what they say it is? Is it something different? Can we script it in our own way, or do we have to follow a certain kind of pro forma?
two primary areas of research. At least the studios I've been conducting have been involved in two areas. The first one is looking at post-digital techniques of representation, and on the other area is synchronous robotics. So this overall research program, those two areas, involve motion control, simulation, choreography, material propensity, and logistics. And that this this setup of multiple and synchronous robotics starts to challenge Euclidean space and geometry, in which we have become accustomed to flattening everything. We basically go through a series of techniques of flattening in order to be able to represent material form. That this, I think, real-time synchronous robotics begins to allow us to get to work in space, in real time, and with matter in, as you often say, in flux, okay? So that you have a new design environment and shaping environment that approaches real time. And that, I think, offers a very new set of possibilities for design. Exploring some of these other topics would be interesting, and an opportunity to attach them to various kinds of interests in design at SCI-Arc, and especially SCI-Arc's extraordinary capacity in simulation and animation seemed to us to also be something that was very important to keep pushing forward, and that moving that as an interface for robotics, and especially multiple robots working in some form of collaboration, was something that we felt SCI-Arc was really probably one of the very few places in the world that could do that.
We hosted this conference called Material Beyond Materials, with the intention of kind of bringing together people in the field and designers, mostly around SCI-Arc, to try and sort of elucidate what, if anything, had composites to do with the kind of future of our industry. And what's interesting in the sort of new flexible composites, which are this tape, carbon fiber or aramid tape, which is a sort of very thin layer that very much functions like a traditional tape, and you can apply in various layers and produce this fantastic array of shapes that could be flat, but it could also take any other bespoke shape, is that the distribution of fibers is not perfect. So they have this sort of custom raw, or not quite raw, but maybe like imperfect finish to it that as it sort of layers up, produces all this fantastic array of of fibers and areas that are basically have less fiber accumulation, that produces to me a kind of complete new different feeling of the way geometry and material distribution can actually take place on a surface. Now, in the context of a proposal for a kind of small pavilion kiosk, we are trying to systematize the way lines will be arrayed on various ways on surfaces, sort of simple codes, mechanisms, or scripts. But then there are a number of simple things that happen when tapes or lines, especially when tape has to be distributed over objects that have creases or corners, that tape has to kind of fold, and in the folding there are various potential problems or accidents or misregistration that begin to happen, which are potentially interesting to the overall aesthetic of the object.
I guess after 10 years of modeling skills or modeling tools, which I think architects have been looking into as ways to draw and design, lately I've been working much more with the idea of 3D scanning as a way to acquire analog material from the reality. So the point of departure of the studios, generally speaking, is not an algorithmic or mathematical understanding of geometry, but actually it's more the acquisition of real texture and real geometry from analog material, which I think changes completely the shift between a synthetic way of comprehending geometry towards an idea about geometry being the point of departure for new surface finishes. Intricate drawings have a depth to them, although they're flat, they have depth to them because from that drawing you can interpolate three-dimensionality. So I think one of the projects in which the point of departure is the scripting and actually the ordering system of the project comes from an understanding of mathematics being the device through which complexity is generated, and the reading of the drawing, the complex drawing, actually creates the geometry of the building. There is a clear intention to hide materiality and to really have all the pictorial quality operate on the surface. So there is a strong idea of hiding as much as possible the tectonic of the surface and actually not making that being the point of departure of the reading of the geometry. Very often, I think in the past 10 years, most of my work actually has been based on the idea of tectonics and the way in which geometry relates to components and components to the whole, and how that becomes a way of construction and fabrication. But in the forefront, I think tectonic is a more hidden process than an expressive one.
Technology recently became very accessible, meaning recently, I'm talking about the last 20, 25 years in architecture. But the truth is, most of the big cultural transformations of architecture in architecture history always come through technology, from the Industrial Revolution and the high level of production of steel to prefab, concrete, blah, 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 modernism, and so on and so forth. So historically, always architecture innovation has been associated with technology. This idea that this is a kind of a new problem, for me, always seems like a little bit bogus. It's just that technology now is very accessible, is more cheap, and is on the tip of our fingers in everyday life.
Through my work and the work in the school, I've always been interested in advancing the topological surface paradigm. The earlier studies were about emphasizing strong discontinuities by combining multiple ontologies. So the students started working with things that really didn't have much of a connection and tried to create new ways in which assemblages could happen. But the problem there, of course, is that how far you can go before you fall into collage. So I think that it tries to move away from collage as just simply combining difference or connecting different objects into one assembly, let's say. When we did the seminar, the ceramic was treated in a very traditional way. Work with the application of the ceramic onto a surface. I think one example of that is the work of Frank Gehry when he was, in the 80s, when he was working on all these fish lamps. I think what is interesting from that research is that it allows you to work at the unit scale with really small objects and then really think at the building scale. And I think so again, ceramics, both how you make the ceramic and how you apply it, and both are the research that we're interested in working on right now. The Mocha shells they are really fat columns. And what they have is that they're very incongruent. What we're working with is that different ceramic tiles that shift from mosaic to roof tiles. The roof tiles are 3D and mosaics are small and 2D. I think that, let's say, incongruency is in the studio, applied finishes in the seminar, and then the combination of both is in the Mocha project.
Digital fabrication and the process of making physical things or objects has been an essential part of our process. Because models do a really, really good job in approximating reality without pretending to be reality, unlike renderings that kind of do the opposite. So we use them less as a final product or as a presentation tool, but as a prototype to develop and explore materiality, spatial effects, and color. In my design studio, I've been focusing mostly on computational models of aggregation. And we've worked with this idea of an aggregated figure as a bottom-up system to multiply single primitives into larger complex geometric forms. And I've used this technique as a means to develop overall massing, aperture, and tectonic articulation of the skin and so on. So the desire here was less about creating homogeneity, but more a sense of incongruency, disruption, and deformation within a larger massing idea. Advances in architecture have always been, at least to some degree, tied to advancement in material technology. And I'm less interested in the performance efficiency of new materials, but much more in a material behavior that is able to create some sort of an effect that goes beyond what the standard palette of architectural materials can do. For example, in our most recent project, we have been working on what we call an animated aperture, which is essentially a window or opening that is constantly in flux without using any mechanical devices. So now this idea of a moving facade or window frame that eliminates mechanical parts altogether and replaces them with a complex mixture of material properties that operate much more on a molecular level and are able to react to environmental forces, like in this case wind, in a much more sensual way. I'm really interested in designing our own materials. And recent development in advanced composites allows us to mix material properties and go from something that is completely stiff or rigid to something very flexible within one material and one component. And a lot of this technology was initially developed for the medical field to simulate joint behavior in prosthetics, for example, and is now slowly becoming affordable and usable in a much more architectural scale.
My vertical studio here at SCI-Arc is called the Imbalancing Active Entropic Architecture, and that studio was dealing very much with a topic that we call synthetic digital ecologies. And the notion of synthetic digital ecologies really is looking at how synthetic systems in architecture can begin to incorporate systems of organic matter. And in that studio, we were really looking at a kind of exhaustion with the purity of geometrical investigation and how we could begin to work with material agency and geometry together. And we were designing prototypes that would begin to transform the local environmental conditions based on water collection and distribution. And finally beginning to look at actuating that with things like Arduino and servo motors, so how we could really begin to incorporate sort of actuating behaviors into these material systems. That we've worked on called the hydrophile hydrodynamic green roof. The proposal is really to look at how a vegetated roof, a green roof, could begin to channel water and begin to become a really performative constituent of the architecture. And then that's coupled with a kind of formal logic where the roof pulls down into the interior of the building, becoming a more immersive space where you really have a chance to engage with that hydrodynamic roof.
Messy computation is the idea that there's really no reason why we need to have clean techniques when using the computer. And I'm really more interested now in moving and shifting in between different software platforms. There are now softwares available that have an immense computational ability, whereas like ZBrush and Mudbox, they still require craft. There's no pushing the button and expecting something to come out the back end. And I would say I don't know if it's a post-scripting attitude, but it's definitely detouring around scripting a little bit. And so that's the area where I'm working right now is kind of bringing back the intuition and finding softwares and different platforms that I can move in and out of freely without really knowing what's going to come out at the end. So what we did last year for Cantilever was take on the idea of composites in a contemporary way. First off, building with composites, it's really difficult because it's like building with fluids. We also wanted to deal with what I call structural tattoos, which is an idea of applying a graphic, which is simultaneously a structural reinforcement area to the piece to increase performance, but also create different kinds of graphic and atmospheric effects on the piece. And of course, it involves molding and molds and tools that you need to form the composite are of course a hot topic right now, and I think one of the biggest hurdles for composite construction.
There is an argument, a general argument, that the only person who is really a radical person is the person who is prepared to countenance the possibility that you could be completely wrong. There are not so many people like that. But what I think, and I'm not saying the school ever is entirely this or almost this, but at least as long as I do this, the ingredient is there. So I would say that the SCI-Arc paradigm at its best is not an affiliation, it's a tension between options or opportunities.
I want to, before we start, maybe real quick, thank a few people that made the movie possible, especially Eric and Tanan, who was super supportive throughout the whole process, and also made the movie financially possible. I also want to thank all the faculty for not only contributing to the film, but also providing footage for the students' work and for their own work for the film. I want to thank Marceline especially for doing all the interviews and putting some really great questions together. And special thanks to Ryan Martinez, who did an amazing job filming and editing the movie. So, as Hernan was already saying, the movie was shown at the conference or at the symposium in Paris at the Pompidou Center in the main lobby. It was also installed there on a big, large video screen. And SCI-Arc was invited amongst 15 schools to show basically their take on the subject. And I think SCI-Arc through that movie got a lot of exposure to not only to students, but also to professionals. A lot of offices send their advanced geometry units there. So it's, in some sense, the event is scientific / technical / innovative, and it was this year, I would say, pretty heavy on robotics and scripting. And one statement we got from the curator from the Pompidou, who was really excited supporter for the event. He said that for him, SCI-Arc's movie stood out as it explores like a speculative aspect of technology rather than just using it as a geometric problem solver. And I thought that's kind of like a good, maybe shoe-in into like a first question to you guys. This kind of like speculative approach that Lemonnier talks about. Eric talks a little bit about this too, about the idea of like scrutinizing the robots rather than just using the robotic lab as some sort of a performer out of the box kind of thing. And maybe Peter and Andrew, maybe you guys can speak a little bit to that. What how the robotic lab, what was the making of it? What was the thinking behind it? And then kind of where do you guys see this going from here on forward?
I wasn't involved in the making of it.
Well, I think that one of the fundamental aspects of the lab is that it's at SCI-Arc. And I think that's what's important, is actually that it's not, robots in themselves are not that interesting. And I don't think that, we haven't done anything relative to making a new idea about a robot. And that robots have been around for about 50 years. So what's new, I think, is the idea of using robotics as a design platform and not just a fabrication tool set. And I think that's made possible by situating this in a school that's very design focused. And that's not been done before, to my knowledge. So other schools have engineering, mechanical engineering, and other disciplines that would approach robotics from either a very computational point of view in terms of ideas about artificial intelligence, or on the other hand, relative to manufacturing. So what I think is important is that it's the whole package, and I think that's what comes across in this film. And that it's actually the understanding of having a whole set of tools being operated on and examined simultaneously. And I think there's also, at least in my interest, is in bringing the digital forward and in bringing the digital and the physical closer together. And I think that's the moment in which we're in. And I think SCI-Arc's really well positioned to really do this. And I think that we're, in a year and a half, the students have done amazing work in my understanding, I think, and a wide range of experiments have been run in the robot house that are really quite new. I mean, I think that in many ways we're actually starting a new design paradigm. At least I see it that way, that we're actually building a new design platform and a new design paradigm.
You agree?
Yeah. No, I wasn't involved. I mean, I came late to the game. I mean, I'm really a fortunate, almost a bystander in some ways. But I think one of the things that's really great about it is the incredibly open-ended approach, both sort of into the robots and then what we put on the end of them in a way. I mean, they're perfectly they're more generic in a way than other machines that we typically access in, let's say, in a shop or at a computer, and that we have almost the way that we work into them is totally open-ended, and the stuff that we work off the end of them. And I think that's the sort of spirit of that place for me, and all of the different things that come out of that work have to do with basically that kind of idea, to sort of experiment with the beginning and the end and use the robot as a kind of perfectly generic middleman or something.
I mean, a lot of the other work, the robotic work, at least at the symposium, had to do very much just with a fabrication tool. I mean, it's exactly what you're saying, that this is not the laboratory. And I'm just wondering, is it excluding that in your guys' opinion, or is it a way how to maybe expand it also to become a fabrication tool, or is it to stay purely experimental, the lab?
I think it can be many things, and I think there's many possible ways to approach it, and I think that we're seeing different ways developing here. I don't think fabrication is excluded necessarily. I think one thing, with Eric and Ming at the beginning discussing this, one of the objectives was to focus on additive fabrication, right? Instead of subtractive methods, which we already have shop tools to do that. So I think that is one area of fabrication where I think the other aspect is something that was brought up in the film by Tom and also Marcelo about the potentials of advanced composite materials as an additive fabrication mode in which we can also start to look at things like free-form fabrication, so getting off of molds as much as possible. And this idea of collaborative robotics is, I think, very important to that. The idea that we've actually, in many ways, violated a lot of industrial models there by using small robots, by putting them very close together, and in unusual arrangements that allow for synchronous and collaborative behaviors that could start to work with materials in new ways. So I think it's also possible to see progression towards really fundamentally new ways of making things.
Eric talks about in the movie about that SCI-Arc's paradigm is not so much an affiliation, but much more tension between possibilities at school. And I think it's a great description of SCI-Arc, but there seems to be some sort of a shared desire or like some sort of a common theme amongst at least the people in the film that has to do with some sort of an opposition to the purity of geometric investigation. I mean, Hernan talks about the corruption or producing a level of corruption. You know, in Andrew's, some of the early work you deal with the accident allowed or the unexpected to produce that. Tom talks about messy computation. Florencia talks about incongruency, etc. So I want to hear a little bit from you guys if you agree to that, A, and B, how you kind of see that in your own work, and what is it reacting to, or what is that a reaction to, that kind of development, if there is such a thing as it being similar maybe?
Well, I think the notion of virtuosity is currently being redefined in a sense of, maybe over the past 10 years, virtuosity had to do with the sort of control over geometry in specific interfaces. I mean, a lot of the software Maya, alias the precursor, very much about kind of formal dexterity, that coming out of the computational environment directly into tooling and CNC fabrication. And I think a lot of the stuff that Peter and Andrew were just talking about with the robotics lab and the whole notion of a kind of forward kinematic way of working where there is a potential to intervene in the workflow as that occurs, I think that's played into also this desire to, in some ways, subvert the conventions of some of those tools that we use. And so I think that's where, like Tom's talking about messy computation, I'm talking about the entropic potentials of architecture or matter in flux, Florencia with the incongruous. So I think that many of us are really pursuing that currently. So I'd agree with your characterization of it.
I think that it also has to do with how many years you have certain control of the tools. And I wish for this I had a voiceover in British, not like seeing myself in the screen. Anyway, I'll keep on with my accent. I write it down, you talk about. So I think that it has to do with the ability that we have now to really go the next step. I think that if you look at the work, the earlier work, you see that it's very much a default to what the machine can do. And I think that now that there's a lot more control, I guess that the same thing, I remember, Peter, when you started with the robots, it was very much about creating the stage for the things to happen. And not so much to, before the robots came, you know, like for 2 years.
Yeah.
And so kind of, and now once the robot arrived, then, then you have maybe 2 more years until you start to figure out what starts to come out of them. So with computation, we had many years, I think 10 years of work. And at the beginning, I mean, you see year by year, and then you see how primitive it looks, the earlier work, and how there's now new venues, and also how similar. Because you see work in many universities, and then it happening in Europe and not, without any connections, and the work was very similar. And now you see branches, of that. And I think it has to do with this advanced knowledge. You get better at it, so you can try new things, you can advance the mechanisms. So I think that each of the faculties it's trying to kind of challenge few things, but only after you have really acquired the knowledge. I don't think that you can do that before you acquire the knowledge. Like you cannot make a statement of, there's certain things that I'm going to change before you really get to know. So you start default in a way, and then you move on. So I don't think that Tom Wiscombe said the same thing 5 years ago. He had, now that he has more control, he can really start to think about messy computation and so on. And I think that's the same for everybody. And I think that's what's interesting from this moment, at least in SCI-Arc, is that it's really looking at the things that can be challenged with the, control of the machine and so on.
Hanan spoke a little bit about what's kind of unique also about SCI-Arc is that pretty much everybody has a practice, and there's a pretty symbiotic relationship between what you guys do in the office and what how you're teaching research are connected with each other. I'm just wondering if you guys could speak, maybe each one of you, a little bit about that, how things overlap, and like certain topics in the office kind of like come into the studio and vice versa. Move back and forth between teaching and practicing architecture. And Andrew, do you want to?
Yeah, I mean, I probably have the least professional office of anybody up here. A lot of my work, I mean, they're basically the same thing, because let's say the way that I've financed the stuff I do in my office has been primarily through research grants, and which I've gotten through more traditional academic channels that have then fed into projects which have potential to inform future professional work, like in like sort of real world work. So for me, a lot of that stuff, that sort of speculative work that's let's say focused towards a very specific research agenda, oftentimes spirals out of control and produces, I mean, again, this has a lot to do with some of the stuff that's already been talked about, kind of unexpected tropes or avenues or directions that the work might go, but has started with a point that was, or let's say at a position or from a perspective of solving dust mitigation in Owens Lake. I mean, which I have honestly no interest in, but other people do, and they'll give you a little bit of money to look at those things, and they'll provide technology for you to look at that, and then all these other things that kind of come out of that. And that's basically how my office, in quotes, is structured right now. I mean, I'd say that's the spirit of the place as we wait for work.
I think that if there was no feedback between research, I mean, you could call it research, for the lack of us making huge buildings and concert halls and housing projects and so on, So what happens is that you really have to focus on understanding, what is the content of the work, and not so much developing work. So I think it's what is important is that the kind of research that is done in studios and in offices, it's similar to the research that starts to happen at SCI-Arc. So it is, it is necessarily connected, between the two. And I also think that it's, something a little bit to the previous question. I think that it's really important in that sense, the kind of discourse that happens in regard to the communication between faculty at SCI-Arc. Sometimes you imagine that a review is just simply some statements in regard to a particular project, but I do think that it's also an exchange of ideas between the different faculty. Or, when we teach together a few classes, and now the studios have a lot more independence than before. Before we had more of kind of curriculum, control more some of the classes, and through the years, it has been that it's kind of more a bottom-up curriculum, where you come up with certain ideas and that starts to build up, kind of the different programs. So I think that that's something really important in regard to the voice of how faculties, of what faculty is working on, and then the things that can be tested in school and how it can change. Any traditional university would have a structural curriculum that lasts 5 years or more, or 7 years, until some changes can happen. And then you can try that, or maybe we go from housing to, to institutional buildings. So that doesn't happen here at SCI-Arc. You can really change content from one year to the next one. And so I think that flexibility allows for a kind of an ongoing discussion of what people are interested in and how you really testing it in the school. And it can happen in an institution that is as independent as SCI-Arc, I think.
Yeah, I think that's a great point about the kind of discussions that go on between the various faculty, and even in the core studios where we're sharing a project or a problem, and each faculty member is kind of pursuing that in a very different way, but we all, at the end of the day, sit down and really start to exchange in terms of those different attitudes and postures. And I think that you'll see also getting played out in the seminars and vertical studios. And I would say also, well, for me, the upcoming show in the SCI-Arc Gallery, that's another venue in the school where the kind of work that we're doing in our practices gets sort of exposed and discussed. As Eric always talks about, that as a platform for debate, and also for engaging with students in terms of that sort of workshop setup where there is a collaborative moment of helping to create that installation. So I think SCI-Arc in that sense is very unique when compared with many other schools.
There's so many dimensions to that relationship, I think, between what we do at SCI-Arc and our own practices. And in my case, I like to think that there is definitely continuity, and I can see that, for instance, this robotics initiative is very continuous in many ways with work that we launched even a decade ago dealing with composites and robotics. So clearly there is continuity, but I also like to think that the language that we have developed in our practice is specific, and that I tend to pursue an interest in ideas and working more with students and developing curriculum around ideas rather than a formal agenda that's particular to my practice. That I tend to prefer to work that way in the context of teaching. But I do think that it's an incredible opportunity for all of us to have this open platform in which we, as was stated, that we have in fact a lot of flexibility and responsiveness to be able to develop new ideas and to try different things out and to take risks. And I think we have an incredible student body here that's willing to take enormous risks. And if we think about it in relation to at least in the context of the robot house, that students have done, I think, just an incredible job in terms of jumping into the deep end of a really deep pool with fearless. And that's just, for me, just a wonderful
thing to be able to participate in.
Yeah. Maybe we'll I have a few more questions, but then maybe we'll cut this a little short. I wanted to ask Marceline maybe to maybe speak a little bit about your studio that was under the topic of synthetic digital ecologies. And kind of like speak a little bit about the specific tools and techniques you have been engaging with in terms of representational tools. And maybe you can speak a little bit about that.
Well, in that studio, again, it had to do with this issue of how the digital workflow, that conventional sort of top-down design in the digital environment and then fabricate in the sort of physical materiality, was really looking at, as I said in the video, something we called matter in flux, where through taking a casting process and specifically, owning that discussion that, of course, we all know that today the idea of mold making and casting is considered sort of antiquated because often you're just limited to the production of serial parts, but starting to kind of activate the space of the casting, so to create a differential outcome through what you do with the mold. Some students also started to actuate that with servo motors and Arduino in terms of pneumatic inflation of silicone bladders or a kind of embedding wire filament into also a system of silicone bladders for water catchment and sort of condensation capture. The idea was about how we could create sort of infrastructures that would begin to engage with what we call the entropic potentials of architecture, where in that case moisture flow, rather than saying that that's something we don't want in a building, but to say, okay, how do we actively engage with channeling moisture through a building, through a piece of architecture. And so in that sense, a lot of the casting materials and working with actuation became very important in terms of how you animate material quite literally as opposed to computational animations.
I want to ask Andrew a little bit about what you said in the movie about you seeing yourself as part of a post-digital movement, and that your interest has to do more with process and objects rather than technology and affects. And maybe speak a little bit about how your current research project that deals with center position landform and 3D projection, how that developed, and maybe you can elaborate a little bit more on what you're doing.
What ended up happening, a landscape architect saw that work and thought that it was might be a valuable tool to begin to prototype or model landform, physical models, and we wrote a grant. And what ended up happening, and I think this gets a little bit to sort of the post-digital question, is that sand became, let's say, a simulation tool that was, we typically think of simulation tools as being things that exist in a kind of digital environment, and that thing moved that into the physical realm. And there's nothing about it that it translates and simulates material behavior that obviously would operate at a much larger scale, but allows us to do it in a controlled way inside of an office. And I think this is a little bit of what probably everyone's been talking about is the, let's say, the sort of mastery of something, or moving towards something, and then in that process beginning to kind of unwind it and test its limits and its potentials and the sort of messy part in between. So really it's a kind of interest in the messiness, and then producing a virtuosity through being able to predict with a fairly high degree of certainty, sort of in a simulated way, a larger physical thing, but then also kind of screwing with it as you go about your business, I guess. So that's sort of what that project is about, or is developed into.
Okay. I don't know, maybe we can open this up a little bit to the audience for maybe questions to anybody up here. You guys have any questions?
Do you guys have a sense of the way representation with the new forms of, I guess, what we call advanced geometry? Like, it seems where maybe the last 10 years there was a high there was like a high focus on actual animation and renderings. It seems like now, especially with the robots, a lot of that stuff exists. Like the robots exist in film more so than in physical objects more often than not.
And I think a lot of the work that we saw today also seems to exist in film and through animations. So it seems like the role of representation, the role of drawings has changed a little bit, and I'm wondering maybe if you guys could speak to that, and maybe in your own work and how you represent what you do with in these new mediums that you're working in.
I would just say that I don't think that the role of drawing has changed at all. I think it's silly to think that we're not going to have to produce some form of, I don't agree with the premise that eventually drawings will go away altogether. We'll ultimately produce things that they may take on a different form or a different shape, but I think we'll continue to produce things that we will call drawings. We might look at them in different ways and in different services, but I don't think that I don't think that 2D the sort of two-dimensional representational surface is dead quite yet. And I think if we start to make that claim and we start to sort of push things closer and closer and closer to real time solely, and we don't slow things down every once in a while, I'm really not sure what we're going to talk about. I mean that as like the sort of discourse, the discipline of architecture. I mean, we have to have things other than buildings to talk about, and if we're just basically producing things in real time constantly, and that's the goal, we're out of a job. I mean that. So I don't think that you could say that things have changed so much, and if they have, we're in trouble.
But let me just say one thing in regard to that. I mean, I agree with that. I don't think, like calling architecture is always thinking, oh, we're like, really in the new era or something. I think that there's always change ongoing. I think that what is problematic is when I see a little bit some of the current work in the school is when there's a little bit of an issue of nostalgia of representation. So it's not so much that you are challenging representation to advance it, whichever means that might take, a robot or an animation and so on. But I think that the fact that the kind of nostalgia of the drawing, like remember when we had axos and they were more interesting than renders, or remember when we had only plans and sections, or a particular view of seeing. For many years there was an overload of the render, and so then there's a kind of rejection of the render. I don't think that it goes. What I was saying earlier is that there's always an advancement in which you start to understand things that doesn't erase previous step, but mostly what it does is it advances. I don't think that just like bringing back certain techniques, traditional techniques of representation, help in kind of canceling other techniques that were really getting a lot more, let's say, precise. I think it's interesting when you start, you never forget certain means of representation. You're not going to say the plan is over, or no more sections, but how these new tools let you see again the sections, and those things are really problematic right now. You end up doing a 3D model, cutting the section in AutoCAD. It's kind of sad that you don't see. And I think that in an office that can happen, in a professional office where they have to deal with certain issues. I think in an educational environment, you do have to move beyond that and start to see, well, that's not the way that I'm going to do it. That's not the way that they do it in an office. You have an Indian and Chinese companies that do professional renders much better than anybody here. So how we're not going to do a professional render, but we're going to do a very, a render that it's like, that it starts to kind of play out other things that are a lot more attuned with the things that we're talking about in terms of advancing design and technology.
I think it also depends upon how we look at the word drawing itself. That representation and drawing, I don't think, are always the same thing, always collapsed in the same space. That drawing can actually be the drawing of something through a space. So if, for instance, in some of the work that Andrew's students have done with the drawing of a hot wire through a space, and the fact that a piece of foam happens to get in the way, that, I would say that the act of drawing there it's somehow registered. It's something between model and what we conventionally think of as a two-dimensional plane of representation. So I do think that these ways of working are opening up maybe sort of novel ways of formulating the drawing and the space of representation vis-a-vis what is being represented vis-a-vis an object.
Yeah, I think that there's definitely, new modes of representation that are being explored and that can be explored. And I don't think the drawing per se is the issue. But I do think that the whole technology around flattening and going through the whole flattening process that ultimately leads to industrial geometry is something that we need to challenge. And I do think that we have opportunities now with different techniques that we can layer together that allow us to begin to work in another space that, at least in my understanding, is kind of a half virtual world in which we can start to think of things both in a simulation environment and in a physical environment simultaneously, or to cross back and forth. And I think Andrew brought that up in the video in a way that was very good, and that suggests that yes, we can collapse, or at least we can begin to consider the possibility of collapsing representation into the thing itself. But that's not necessarily a value in and of itself, but that then if we can do it, as was suggested, then we can dilate it. We can do many different things out of that. So I think that's much more the situation that we're developing, that we're finding ourselves in, and that's a very experimental and open-ended circumstance. So for instance, this semester in my studio, we started out with the premise that we would do half fabrication and half cinematography, so that we're able to start to combine different modes and to use different techniques in different process sequences than might conventionally have been used. So I think it's an open and a very exciting set of topics that are opening up for us right now.
Yeah. Okay, any more questions?
Time up.
No?
You get 4 answers here, too.
Yeah, exactly. It's like
it's
a commitment.
I wanted to say, I think the video was really well edited. So I just wanted to congratulate, except for the voice. I think you should have that. But I just wanted to.
You want to have a British accent next time?
Yes, next time it was an always British accent.
Yeah, I think we'd all like to thank
Ryan
and
Ryan,
very much.
Herwig and Ryan,
Yeah.
that was really, really phenomenal.
All right. Well, thank you guys.
Thank you.
Have some wine.